Here we go. It is now recording, and we're going to get the class started. A few things to kind of go over first. The YouTube link to all the recording is actually in Canvas, is right here. So go there to take a look at all the videos if you want to. I mean, it's not required. So once you get here, you go to videos, and then you just go by the date. So the one that I recorded on Monday is right here because that's the date. It is September 8th. So when I teach the Wednesday class, I will assume that people have watched the video that I recorded on Monday because that's what we talked about last Wednesday. Is that okay? So you guys kind of have to do what you can to kind of keep up with the class in terms of the lecture. If you can show up on Mondays, I think it's even better. There's a few people actually show up on Monday. I think there were about eight of the people in this class showed up on Monday, and there were some question and answer session also. So that's a really good way for learning is really to be in class, asking questions, and have a discussion. So anyway, this is the resource, and you need to use this resource because of the quote unquote hybrid portion of this class. So do we have any questions about the how to access the video and what I expect people to do in this class in terms of the Monday lecture? No questions? All right. So if there are no questions, I will continue from where I ended up on Monday, which is section 7. So in section 7 of the condition and conditional statement module, we were about to take a look at this code here to figure out what it is and what the behavior of this code. On Monday, I also talked about how there are two conditional statements here. One conditional statement is here. The other conditional statement would treat this highlighted block as the else statement. So this entire block is really just the else statement corresponding to the to the outer conditional statement that starts on line 1. So are we getting that those concepts? How things are nested? All right. But this is also why it is important to understand BNF. Okay, I hope you guys still remember BNF. That's one of the first things that we talk about in this class. Because once we understand BNF, we can then look at this code and look at and understand the structure of the code. Okay, because even though every single symbol, every single word, we seem to understand what it means, the structure is not as easy to figure out. Okay, in other words, do we have a conditional statement inside another statement? Well, if you don't understand the BNF portion, then you may not understand how this whole thing is structured. So I can also give you a pictorial representation of this code here, and it is down here. So you can see how this is the overall logic. So if I were to zoom out, okay, let me zoom out a little bit and some more. So you may not be able to see all the text, okay, because that's not the idea. The idea is we want to look at the entire map here, and then we can identify that this portion here is a conditional statement itself, and it is being a component of the false branch of the bigger or the enclosing conditional statement, which is here. So are we doing okay so far? Looking at the pictorial representation and understand how a conditional statement, which is this part here, is enclosed entirely within the outer conditional statement. It's kind of like having a folder, including another folder. Do we have any questions about this part? Okay, we see, I see some people turning their head, so they're okay. So for the people who did not turn the head, what is your question? Okay. You can say something like, I don't know where to begin, or I do not understand, what is the structure of a conditional statement. The structure of a conditional statement was something that we talked about on Monday. This is the structure of a conditional statement. It has a condition to evaluate. It has a branch to branch to when the condition is true, and it has another branch to branch to when the condition is false. But after the then branch and the else branch, they have to merge back into the same spot. That is the structure of a conditional statement. So when you look at the bigger picture, I know you guys cannot really read the text, but that's not the full point. Once again, the point is looking at it from the picture perspective. So when you look at this bigger picture, this particular thing, okay, this entire portion here, if you look at it as only one single rectangle, then the outer conditional statement is really just a conditional statement that is including this entire conditional statement as one single item for the else branch. So that's the point that I'm trying to make. Are we okay with that concept? It is the concept of embedding or nesting. Okay, you can use you know quite a few words to describe it, but that's basically what it is. This is really, really important in programming because in programming we only have like four-ish, control structures or different kind of statements to control the flow of the execution. So the complexity of algorithms come from the fact that we can nest things. You can have a conditional statement in a loop. That loop in return is in another conditional statement, which in return is in another conditional statement, and so on. That is how program code can be complicated because of the nesting nature. So all right. So what we'll do today, the first thing is to go through a trace, and we're going to go back to an earlier um, piece of code, which is the original finding the maximum of two variables, which is this code here, find max two. And then we'll just go through a trace to figure out, okay, so when this code executes, how do we trace it? Because that's going to be your homework. Okay, your homework is to trace something that's more complicated than this, but in the format that is consistent with what we're going to do here. So to do that, I am going to go to my Google Drive and create a document that you guys will all have access to. So it will be in the CI. Let me go back to my drive, go to CISP 300, and the shared folder. Anything I create in this shared folder is visible to you. So I'm going to create a new folder or new document, a new sheet that is named after today's date. So it's easy for you to find, the spreadsheet or the Google sheet that we work on today. Today is 2025 0910 because it's September 10th. So this is the trace of the code that is here. Are we doing okay so far? What I'm about to do. Okay. So the way I do this in my class, I just use a trick like this. Okay, I take a little snapshot on the screen and then always show it on top of the other window. So this way I don't lose track of the algorithm that I'm trying to execute. So now I can put this somewhere, like the corner of the screen, go back here, and now I can focus on the construction of the trace itself. Yes. So this is specific to Linux. I'm not sure how to do it in Windows. I'm fairly sure that there might be ways to do it in Windows too, but I'm using Linux, in this case. So the way that I did it was this. So I go to the menu for the window itself, and then I go to always on top and make sure that radio button is on. But that may not work in Windows. That is correct. I have to do it, but you may not need to do it because your screen has a higher resolution than the projector. The projector has a resolution of 1280 by 720, which is a 720p resolution, which is considered to be really low by laptop standards. So you are probably having a 1080p resolution by kind of default. So that means you can fit a lot more stuff than I can put on the projector. So you can just resize the spreadsheet window so it's not taking the entire screen. And then just take a snapshot like what I did, but you don't need it to overlap with the screen because you have more real estate on your screen. But if you want to do the always on top option, That might be ways to do it too in Windows. I just don't know how to do it. Yeah. But good question. Good question. One of the questions that I cannot answer. All right. So in terms of the trays, we have a few columns, right? So because you have all done the homework assignment that's due today, right? Okay, I see a lot of nods, okay, and not a whole lot of faces going to, what homework? Yeah, so that's good, okay? We already know that there's a column dedicated to line number. This is how we keep track of on which line the result of which line is making what changes to what variables. And then we have one column per variable that is involved in the algorithm. So we can see in this particular algorithm, there are three variables. We have X, we have Y, we also have Z. Okay, so we got X, we got Y, we got Z. And typically, I would also use one column for comments, which is really just anything you want to talk about. At this point, anything that we want to add to help annotate what we are doing in this algorithm. The first row after the header is called pre, which is precondition. In other words, what do we know about each of these variables before the algorithm starts execution? So in this case, because if you look at the algorithm, there are no assignment statements other than line 2 and line 4, and X and Y are being used before the line 2 and line 4. So that means I have to tell you what X and Y are in order for this algorithm to make sense. So we'll go ahead and start with 2 and 3. Okay. Z, on the other hand, it doesn't really matter what we put here because we are going to overwrite the value of Z anyway. So we can just say that, well, we don't know what is in Z because it's not important. So are we doing okay so far with how I set up the precondition of the trace of the algorithm that is appearing on the upper right hand side corner? Yep. hmm I'm just making assumptions so that so that I can go through the code in one particular go. I can force the code to go through one branch with this particular setup, and then I'm going to reverse it for another trace so that if I will force it to go through the other branch. Because this is the whole idea is to illustrate what a conditional statement does before we get to the more complicated conditional statement. So we doing okay so far? All right. All right, so now we go to line one. Okay, so line one is interesting because it doesn't change anything. So if it doesn't change anything, you guys go like, so there's nothing to talk about. Well, that is not true because if it evaluates a condition, which in this case is x is greater than y, then in the comments column, we have to indicate what is the result of that comparison. So I would just go like, x is greater than y is it true or false? It is false. It is false because x has a value of 2 and y has a value of 3. So 2 is greater than 3 is false. Okay. So we'll write down, this is false. And in this class, if you just say f, I will understand it as false. If you put a 0 here, I also understand it as false. Obviously, if you want to spell out the entire word, that's okay with me too. Okay. I just need to know that you evaluate the condition, and as a result, you know where it is supposed to go. So where is the execution going to continue knowing that the condition on line 1 is false? Where do we go? We go to line 4. Very good. Okay, so we go straight to line 4 because line 4 is corresponding to the else branch of the conditional statement. So now we go to line 4. Line 4 has one thing to do. It is an assignment statement. So we evaluate the right-hand side. We figure out the value of y. Y has a value of 3. And then we use that value to change the variable specified on the left-hand side of the assignment, which is z. So at this point, z is updated to the same value of y. And then where do we go? What is the next row? Post. Post for post condition, which is basically saying, yep, we are done here. Okay, this is the entire execution of this particular algorithm. So I'm going to pause and see if there are any questions about this particular trace. Any questions about? Yes, go ahead. Yes. So that came from, I didn't quite cover that in the lecture, but it came from the reading module for assignment. So when something is not changed, I don't even bother to copy the value because because that way it's going to be really busy. So we only update a cell when the corresponding variable is changed or it is involved on the left-hand side of an assignment. Okay. Now, at this point, if you turn in the first assignment homework, and you go like, oh, but I fill in every single cell, it's okay, not a problem. Okay, yeah, because for simpler algorithm, that approach is okay. Okay, it just takes a little bit more of your time. I actually looked at how people edit the document, and I saw a few people filling all the values, and then they go back and erase or clear the cells that do not need to have a value in. That's perfectly okay as well. Okay. And yes, I actually do that sort of thing. I actually look at the edit history of the document that you turn in, and if I spot anything like copy and paste, like a whole big block of copy and paste, I would think a little about that a little bit. Okay. All right. So are we good with this particular trace before we kind of trace it in a slightly different way? We good? Yep. Okay. So now I'll do the super lazy thing, which is just to duplicate the entire sheet and call that sheet two. Okay. In fact, I'm going to change the name. Okay. So we'll go ahead and call this the else branch because in this case it is taking the else branch of the conditional statement, and then sheet 2 is going to be called the then branch because it's going to be set up to take the then branch. So to do that, I'm going to erase a bunch of stuff which is here, and all I have to do is to flip the values of x and y like that. So now, this is the precondition. The precondition says, what if we start with x having a value of 3 to begin with and y having a value of 2 to begin with? How will the algorithm execute in this case? We still get to line 1 because line 1 is evaluating a condition. In the comments column, we still have to indicate x is greater than y is true. Very good. Okay, it is true this time. So that means what is the next line I should get to? Line 2. That is correct. So line 2 says, z equals x. So now z has the value of x, which is 3. So we put a 3 here. All right, so it is tricky now because when you look at the code, there are additional lines after line 2. What is the next line? What should I put here in cell A5? Post. Okay, that is correct because it doesn't matter which branch you take. As soon as you're done with the branch, you get to the end, and since there are no additional lines after line 4, so we get to post right away after line 2. Do we have any questions about how this algorithm traces in this particular case? No questions? All right. So if there are no questions about this, then we go back and take a look at the more complex example, which is in section 7. So I'm going to close this. Okay, there we go. And then we skip all the way to section 7 because that's where I left off on Monday's lecture. Um, so now we have, well, I guess the first thing we can do is really just to look at it from the perspective of the picture, okay, the flow chart. So let's do that. And to do that, I am going to use my editor so that we can track, what value is in which variable. So that makes it a little bit easier. Okay, we go to mouse pad. There we go. And this time we have W, X, Y, Z. So I'm just going to say, okay, let's make assumptions about all those variables. So I'm going to say, what if W equals to 5, X equals to 10, and then y equals to, say, 7. So these are the initial values of the variables. Once again, z does not have any known value at this point. So now you're starting at the starting point, right? You evaluate this condition. What is the result of this condition? Is it true or false? W is greater than or equal to X and W is greater than or equal to Y is false, okay? Because W turns out to be the smallest of the three, so, it is false. Then we follow the false branch into here. So now we have another condition to evaluate, and this time it is asking, is X greater than or equal to Y and X is greater than or equal to X to W? What do you think? It is true, so we follow the true branch. So now we get to this part, and then z eventually gets the value of x, which is 10, and then we get to this merge point, and then from that merge point, we also get to this merge point, and then we conclude the execution of the algorithm. Are we doing okay so far with the pictorial trace of the logic of this code? Okay, so now how do we represent this um, in the text version of this code? It's kind of the same thing. You start with line 1, you indicate that this condition evaluates to false. Then you get to line 3, and then you evaluate this condition, which has a result of true. Then you get to line 4, and then you change the value of x, and then you get to post. All right, is that okay? All right. Um, there are there's actually a trace of this, if I remember. Yep. So there's a trace when x, w, x, y, z are all twos, to begin with. So in that case, if if all of the variables are twos, then this condition is true to begin with because 2 is greater than or equal to 2 and 2 is greater than or equal to 2. Because this condition is true, we follow the true branch to z equals to w. So z gets a value of 2, and then we get to, we go pretty much straight to the end of the whole thing. So that's what this trace is talking about. Do we have any questions about this particular case? And you can also see in this trace, okay, let me get this out of the way. You can also see in this trace, I'm using kind of the standard, except I use the actual value in the variable instead of the variable itself. You can use either because I just need to know that you evaluate the condition and you got it right. Okay. So in this case, 2 is greater than or equal to 2 is true. The condition is true. And so we just move on to line 2, and z is now updated by w, and then we get to post right after, because as soon as you take one of the branches, it would go through all the merge points and it would get to the end of the entire statement. Are we good? All right. Yes. That is correct. You do not need to use the illustration style. The illustration style, which is what you saw up here, is really just good for instructional purposes. To show you, how the paths look like. Eventually, I mean, at first, I think some people will find the pictorial representation easier to understand because they can follow the arrow and also follow the labels of the arrows, right? So some people may find this easier to understand. Um, the best way I can describe this is a crutch. So at first you can use it, but eventually, like somewhere like in the middle of this class, I think it is important not to have to rely on the picture and be able to read the text version and understand what it means. Are we good? All right. All right. So we are now moving on to this portion here, which is asking, what does it mean when we use the word else if? Well, as it turns out, else if is not a single construct. It is a combination of two constructs. In other words, for those of you who know Python, this is the indentation that it would be using when it comes to the nesting level of the statements. But if you don't know Python, that's okay. Okay, so it is expressing the same thing that I have already mentioned earlier, except this time, I used the line feed, to make this more clear. This entire thing from line 4 to line 7 is a conditional statement. Okay? And according to the BNF, a conditional statement is really just a statement, right? So this entire block of code can now become the else statement of the conditional statement that starts on line 1. Okay, I'm just going to pause here because that whole description is can be a little bit much to absorb. So I want to kind of pause here and see if there are any questions about what I just said. No questions? All right. And I don't see anyone taking notes. That means you guys are all familiar with the idea. Yes, correct. So it is a subfolder. This is one level lower compared to the folder corresponding to line 1. Yep. Yep. So that's a good way to kind of visualize is to have a folder containing a folder. So this itself is a folder, and you might ask, so if this entire block is a folder, where are my files? So files cannot contain anything else, right? So your files would be this and this. Those are your files. So those are the files inside this particular folder, but this entire folder is inside the folder corresponding to this particular statement. So this entire thing is one single folder. Are we good? All right. Mm-hmm. Um, all right. So since we're talking about this, it's best to look at it, from the syntax tree perspective or how the whole thing is parsed using BNF. This is basically another picture of this whole thing. You can see how, this is the condition of line 1, right? And this is the condition corresponding to line 3, if I remember correctly. Nope, line 4, sorry. So line 4 has this condition. So the yellow block is actually corresponding to line 4 to line 7. But it is serving as a single component to the conditional statement that started on line 1. This is how one conditional statement is containing another conditional statement. Okay, so that's a good question. Um, so as I talk about this, this is all getting recorded. I can, I double check, kind of from time to time to make sure I'm actually recording because sometimes I would accidentally turn off the recorder and then, the lecture is not recorded anymore. So, so whatever is on the screen and whatever I say is going to be recorded. I cannot record your own thoughts, okay? And also the connections that you have made as I describe the concepts to earlier concepts. So that is what your notes is for, okay? When you write notes, you're not jotting down, everything that I said or all the things that I do on the whiteboard because that part is getting recorded. You are recording your own thoughts. The way that you connect the concepts, that is what you're going to be writing down, okay? Because at the moment, you might say, but Tech, I'm understanding everything. I don't need to write any notes. Well, let's check after the class whether you actually remember everything that you thought that you remember. Because at the time, you can understand everything, but after the class is over, you may not remember what you understood. And that is the importance of taking notes. It makes sure that you have everything recorded. It's not just whatever I talk about, it is also whatever is in your own thoughts. Are we okay so far with that? Okay, because you can call me old school because I am old, so I qualify to be an old schooler. But when I was in college, I had to take a lot of notes. In order to In my case, I took notes in order to stay to pay attention in class. Because if I don't do that, I will start to kind of my mind will start to wander off. Other people take notes because they need to review the notes. So, it is still a very important technique if you want to be successful in college. All right, so uh, let's go ahead and work with. Oh, by the way, this is the syntax tree. It looks really nasty. It looks really nasty. It's really hard to display the entire thing. So I'm gonna have to leave it to you guys to explore this. But the syntax tree tells you how things are grouped. Okay, that is the most important part of the syntax tree. It's telling you how things are grouped. It is really difficult for me to do this, in on a projector. But what you can see is from here all the way to here. That is that's the nested conditional statement. And that whole thing combined into its own conditional statement, which then becomes the else statement of the outer conditional statement. And that becomes a component, of the outer conditional statement. So if you actually spend the time to follow the arrows and follow all the lines, which is not easy, you would now start to understand why BNF is so important. Because BNF dictates how the compiler is going to interpret the text representation of the logic. Are we doing okay so far with that? Yes. Hmm? It is both checking the syntax to make sure syntactically this is correct, but it is also determining what is including what else. Um, this one is not a flowchart. It doesn't tell you how the code is supposed to execute. It tells you how the terminals, how the words and punctuation marks, you know, how they form the structure that became the flowchart. So the two diagrams are related. This diagram, the one that we are looking at right now, is telling you how the computer processes all the words and the punctuation marks in order to come up with the equivalent logic that is here. So this tells you the behavior of the code. This tells you the structure of the code. The second one is called a syntax tree or a variation of a syntax tree. All right. Do we have any questions about the concept of a syntax tree, which is telling you about the structure of something, versus the flowchart, which is telling you the behavior of the represented logic? So is that concept clear? The purpose of each diagram, because they are two different diagrams, but they are related. So we are good. All right. So one other way to look at this, okay, I hope this analogy works. This one is like an org chart. Okay, it tells you who is the CEO, who is the director, who is the team leader, and so on and so forth. Okay, it tells you about the organization of a company. The other one tells you about the operation of the company. Okay, it tells you the CEO is supposed to do this, the director is supposed to do this, the software engineers are supposed to do this, the test engineers are supposed to do this after the software engineers do blah, blah, blah. So this is the operational description of the organization as opposed to this is the org chart. Okay, it just tells you, who is in charge of what and which department has what kind of people and so on and so forth. Okay, so I hope that helps you kind of differentiate between the two diagrams. Now, in this class, I'm not going to spend too much time to reconstruct, the syntax tree. I would just be making assumptions that you guys know how to do it at some point of time. Okay, and this is really important because if you don't know how to do this, then you can look at a piece of code and think that it would work in one way when it works the other way. Okay, I will give you an example. So let's go ahead and look at a particular example, and I'm going to put it into here too. So we'll go ahead and take a look at an example. We'll call this tricky. All right. So the tricky code is going to go like this. I'm just going to say if x is greater than y, and then here we start with two lines, which is indentation. We'll say, z equals to 1. And then over here, we'll also have two spaces in front. We'll say, z gets z plus 1. And then over here, we also have z equals to z plus 1, like so. All right. So this is the little chunk of code that I want to execute. And I'll give you some idea of what x and y start off with, when we actually do the trace. So when you look at this code, what is the structure of this code? That's the question. For those people who learn Python first, they look at this code and go like, oh, lines 2 and 3 are both in the then branch of the conditional statement. Because in Python, the indentation tells you about what is including what. But in C++, that is not the case. Okay, so we'll go ahead and trace it first, and then I'll go back and look at the syntax tree, or the yeah of this whole thing. So the way I'm gonna do this is same trick, okay, but this time I'm gonna include the line number 2. So I'm just gonna take a little bit of this, open it in my little viewer here, make sure it is always on top, put it to the side, and then we'll use another tab for tracing tricky. So trace of tricky. All right, so we have line number as a column. We have x, y, z as variables. So we have one column for each. And then we have comments like so. And then the precondition is, well, we have to know what is in x and y before the algorithm executes, because otherwise we don't know whether x is greater than y or not. So let's just say that x is 3 this time, y is 2 this time. Z has an unknown value to begin with. And now we get to line 1. So on line 1, you go like, oh, heck, we got this, right? This is exactly the same thing of something that we worked with before. I believe that would be the then branch, right? So we know how to do this. We just have to say x is greater than y is true. And then we proceed to line 2. You are correct. Okay, we proceed to line 2. Line 2 is going to put a value of 1 into z, like so. And then we get to, where do we go next? We go to line 3, okay? Yeah, line 3 is going to say, okay, z is incremented by 1. And then we get to line 4, which increments z even one more time. It ends with a value of 3. And then we get to post. So this is what happens when x starts with a value of 3, y starts with a value of 2. Okay, everything looks good? Okay. So now with the other trace, okay, the other trace of tricky is going to look a little bit different. So I'm going to duplicate this whole thing. We'll call it trickier trace of tricky. All right. So this time we're going to change things around a little bit, okay? And to make this code make sense, z this time needs to start with a particular value for no particular reason. Let's start with 23, okay? All right. So we get back to line 1, okay? Line 1 says, okay, we have to evaluate x is greater than y. Oh, I forgot to change these two. Okay, there we go. So x is greater than y is false this time. Okay, you guys go like, okay, we have to go to the else branch, but there are no else branches. So that means you have to locate the end of the conditional statement. Where do we go next? Line 4 or line 3? Visually, it is line 4. You got tricked because syntactically, it is line 3. So we actually proceed to line 3, not 4. So we proceed to line 3, z is incremented by 1, which is 24, and then we get to line 4, where z gets incremented again to 25, and then we get to post. So the question is, why are we going to line 3? Because it would, from the perspective of indentation, line 3 is a part of the then branch. We should skip over that when the condition is false. but from the perspective of the compiler, it is outside of the conditional statement completely. Why? Okay, first of all, does everybody understand what I just said? Line 3 is not a part of the conditional statement at all. Does everybody understand that statement? I'm not asking you why. I'm just asking you, do you understand what I said? Line 3 is on its own. It is not a part of the conditional statement. Is that understood? Yes, go ahead. Explain. Well, I'll explain why, but I want to understand, do you know what I mean when I said line 3 is not a part of the conditional statement? So is that okay? All right. So to understand how this works, okay, let me switch to my tablet because this is where the tablet comes in really handy. Let me see. I need to turn on the screen share first and also go to the notebook for this class. I have one notebook for each class. This is yours. There we go. And then turn on screen share. Yep. All right, that's good. And then I have to turn on the viewer over here. Supernote. Yep, that works. All right. So this is where we left off. This is what I captured on Monday. Okay. So if you have watched the video on Monday, or if you watched the video that I recorded on Monday before today's class, you would know, okay, so we kind of talk about this. So what we'll do is now we move on to talk about the example that we have today, which is if x is greater than y, z equals 1, then we have z equals z plus 1, and then we have z equals z plus 1 again. And you guys are going to complain. It's like, Tech, you use multiple lines to capture this in the on the other side. What did I say on Monday about line feed and multiple spaces? It doesn't matter. Exactly. Okay? It does not matter. Line feed, which is how you break a line and open a new line, versus spaces, they all serve the same purposes. Okay, which is really just to help us tokenize or separate the punctuation marks and the tokens. Okay, so that means the code that we saw earlier, that is, oh, okay, it's still on the screen. It is right here. This code, semantically speaking, is exactly the same as this one. Now, obviously, this one seems to be easier to read, but that's exactly why people got tricked by the spacing or the indentation of line 2 and 3 being the same. People got tricked to associate, oh, that's a block of code, and they are both in the then branch of the conditional statement. Okay? This is why BNF is important. Because when you understand BNF, then you go like, okay, let's pretend that I'm the computer. Okay? The computer says, I just see, I saw the word if, which is a terminal. So at this point, the only kind of statement that can start with the word if is a conditional statement. So the compiler says, I'm expecting the rest of a conditional statement now. Is that okay? So that's from the perspective of the computer, compiler to be even more specific. So now the compiler says, okay, I know I'm expecting a conditional statement. What should I be expecting next? Okay, so what is the BNF of a conditional statement? What is the computer expecting after the word if? What is the terminal? Okay, let's okay. So let me go back to where you can find that description because I always want you guys to be. I want to be sure that you can find the description. So well, probably more helpful when you can actually read what is on the screen. So the BNF. Okay, so if we go all the way back here, I think it's right here. There we go. So this is the BNF or the syntax of a conditional statement. Everything in boldface are terminals. You can see the if is a terminal, right? And I said, yes, the compiler just saw the word if. What is it expecting next? Open parenthesis. Okay. So now switching back to Supernote. So now the computer or the compiler says, oh, great. We are indeed seeing a open parenthesis. Okay. Everything is good. What does the compiler expect next? The condition. Very good. So at this point, I will not talk about the parsing of a condition because that by itself is really complicated. Okay, so we'll just say that, yeah, we can recognize this whole thing is a condition. So this becomes the token of condition. And I use angle brackets in this case because it's harder for me to write in italic. It's harder to differentiate what is italic and what is not, and what is not. So angle brackets is how I use to specify that condition is not a terminal; it is a token. Okay. So what is the compiler expecting after the condition? The close parenthesis. Okay. So do we have a close parenthesis? Excellent. We have a close parenthesis. Great. And what is after that? A statement, a single statement. Okay. So it is expecting a single statement. And what does it see? It sees the word or the terminal Z. So as far as we know, what kind of statement can start with Z? How many different kind of statements have we talked about at this point of this class? We talked about assignment statements from last Wednesday. We talked about conditional statements on this Monday. Those are the only two. So that means Z does not look like if to me. So it cannot be the beginning of a conditional statement. So it must be the beginning of an assignment statement. That is what the compiler is going to think. Okay. So you look at the Z and go like, okay, this is probably the left-hand side of an assignment statement. If it is an assignment statement, what is following the left-hand side, which is a variable? What follows the variable on the left-hand side? The equal symbol, exactly. So now it sees the equal symbol, go like, okay, cool, everything is going as expected. And then what is after the equal symbol? We just call it an expression, right? So in this case, we have a really simple expression, which is 1, okay? So now, this is what we call it an expression, EXPR for expression. So now we have a left-hand side, the single equal symbol followed by an expression. The compiler goes like, woohoo, I just recognized something. Because this entire thing, including the little equal here, the whole thing becomes an assignment. Not an assignment statement, just an assignment, because an assignment is actually an expression. We'll talk about that later, okay? And then what does the compiler see? The semicolon, right? So the semicolon is here, and the compiler goes like, hey, if an assignment is followed by a single semicolon, what is that becoming? What token? Assignment statement. Very good. So we'll just call this ASGNSTMT for assignment statement. And what can assignment statement become? A statement. Very good. So this now becomes a statement. Okay, cool. And from the perspective of the conditional statement, what is the compiler expecting after the close parenthesis? It is the then statement, right? So this statement now becomes the then statement, which is a part of the conditional statement. Is that okay? Are we good so far? What follows the then statement of a conditional statement? You can look up the syntax. Else, potentially, because it's optional. The entire else portion is optional. But that whole optional part has to start with else, the word else. Okay. Does this look like else to you? Nope. So the compiler says there's no else in this conditional statement. So if there's no else in the conditional statement, the conditional statement, this is it for the entire conditional statement. So that means this entire thing, okay, everything all the way up to here, then becomes a conditional statement, which is really just a type of statement. The compiler has now concluded that we are now seeing the end of the entire conditional statement. So when it sees the Z here, it goes like, oh, this has nothing to do with the conditional statement. This is the beginning of another assignment statement. So the assignment statement Z equals Z plus 1 has absolutely nothing to do with the conditional statement. So I'm just going to pause here, okay, because the rest of this is kind of the same. We're just parsing two more assignment statements. So are we kind of understanding the process of how the compiler look at the sequences, not sequences, a single sequence of terminals and formulate the structure of the code? Now, am I expecting you guys to be able to write something to parse this whole thing? No, that's a pretty advanced topic. But intuitively, do you now understand, how to use the BNF specification to help you understand the structure of the code? Yes. About okay, so this whole thing. Yeah, so it is a merge. Okay, let me use additional lines to indicate what goes into this whole thing. So the then statement is one component of a conditional statement. The close parenthesis is one component. The condition is one component. The open paren is one component, and then finally, what started the whole thing is the terminal if. So all of these connect in order to say, oh, now I recognize a conditional statement. But a conditional statement is just a statement. Is that okay? So if you are to redo the discussion of how module 0440 relate to module 0012 and now 0013, because that's conditional statement, are we making that connection between the discussion of BNF, which is kind of dry and abstract and seems to be pretty useless, to what we are now talking about? So are we making that connection? All right. This is also why in many other classes they don't talk about BNF. They just give you samples of code and they just tell you, oh, they want you to learn by example. Okay, in other words, this is in this code, these things are together. In this code, they're not together, and so on. So they're trying to those other professors or textbooks are using the technique called learn by examples. um, I'm using the opposite approach, which is I give you the rules. Okay, I give you, actually what the computer does, and then we work out these cases according to those rules. Okay, so there are two different ways of learning, two different ways of teaching. Some people are more they like one particular way rather than the other. But when you're learning computer science concepts, I think this is just me subjectively. I think it's always better to really learn the rules behind everything, and then you apply those rules, and then you try to apply those rules to make sure that you understand the rules correctly. Okay, but that's just me. That's my take on the whole thing. So are we good with this example? Why, after line one, when the condition is false, we go to line three. Okay. How many people think that this kind of mistake or misunderstanding that line three is a part of the conditional statement happens in real life with real programmers or code or developers? How many think that that actually happens in real life? Okay, yes, it does. Okay, in fact, it happens to me occasionally too. Occasionally I would have forgotten that go like, oh, okay, and then, but the problem is, it is not a syntax error. The compiler says everything is fine, not a problem. It just interprets the code in a way that is not what you intended. That is one of the worst kind of problems that can happen. If the compiler comes back and say, "Oh, there's a syntax error here," it's actually a good thing because now the program is not going to run at all. You are forced to look at the code and go like, "Okay, what's wrong with it?" But if the code is interpreted just incorrectly by the compiler, it runs just not what you think it should do. That's actually worse as a problem. All right. So, shall we proceed, or do we have any additional questions about the parsing of the code that is in this little box here? We are, yes, go ahead. What if x? So that's exactly what we have here in this example. When x is 2, y is 3, then, or what if it is the same? Well, that's what we did with the other case. So it would just go ahead and execute, it would just execute line 2 and then followed by line 3. But line 3 follows line 2, has nothing to do with they are both the then portion. It really has to do with line 3 is whatever statement is following the entire conditional statement. Because line 3 is not a part of the then branch. Yep. Yep. hmm You mean which, this one? Yes. Without the semicolon, you have an assignment. An assignment is really a kind of expression, but I don't want to talk about it as an expression, but it is not considered a statement. So without the semicolon, if you just go, without a semicolon here, if you remove the semicolon, the compiler will bark at you because then it goes like, hey, I don't know what you're trying to say here, okay, because it doesn't recognize this as a statement. The assignment becomes an assignment statement. Yes. hmm All right. So yes, go ahead. Okay, that's a good question. If so, let me see if I understand your question. I think your question is how do we group line 2 and 3 to be one single thing that we want to do when the condition is true? Is that correct? Okay, excellent. That's an excellent question. Um, and I will address it in the next module. That's the whole reason why we have the next module. It is called, okay, does anyone read ahead of the class? What is the next reading module? Go ahead and look for it. I mean, you can use your computer. What is the name of the next reading module? So block statement, exactly. So a block statement is what you need when you say, hey, I got a bunch of stuff to do. I got multiple statements that should be grouped together. So a block statement allows you to do that. Very good. So I like that line of thinking. That's exactly why I sequence the modules the way it is. Excellent. So you do have homework to turn in next week. Okay, so I want to mention that first. So your current homework is, where is it? Pre and post. Nope, nope, this is way past that. All right, so I'm going to turn this on. It becomes visible to you now. So your next homework assignment to turn in is called conditional statement assignment. This assignment is really just saying assignment as in something that you have to turn in. But this is your homework assignment. And let's go ahead and take roll. It is not visible to you yet, so don't try to refresh. So let me go ahead and change this a little bit. I take roll only so that people kind of make a habit of actually showing up in class and hopefully paying attention also in class. Um, but there's really only so much I can do about whether people are paying actual attention in class or not. So I'll give you guys up to 10:15 to do this. And the access code, which is the only thing you need to know, is variable. I'll write it on the whiteboard, so this way it's easy for you guys to remember. Variable. There we go. And then I will release it so that you guys can actually participate. So if you sign in to Canvas now, you should see roll on 20250910. As you guys are doing that, I'm going to present another sequence, another code, and we'll also check this out and find out whether what the compiler is going to think of it. Hmm? Are you guys on the school Wi-Fi? Yep, you have to be on the school Wi-Fi. You got the same thing? What does it say? Yeah, zero out of zero is fine. Okay, it just means that I did not assign any point values, but I can still see that you participated. Yep. But for people who are using VPN, you have to get out of VPN just for a moment, and then you can go back to your protected mode. Shields up again. So you have to take your shield down just to do the transporting. Question? Okay, let me take a look because yeah, I got it. Oh, okay. Can you sign into the school network? Okay. And you're in a computer science class. Okay. All right. I'm gonna turn off the IP filtering. Yeah, I will turn it off. Yep. Because I thought most people want to save some of their 5G traffic by using the school Wi-Fi, and well, I guess 5G is so cheap now, nobody cares. All right, so I just turned off the Wi-Fi, I mean the IP filtering, so everybody should be able to do it. You will still see one over zero, zero over zero, but that's fine. All I need to know is whether you participated or not. Which one? The one due today or the one due next week? The concept of time. Yes. Mm-hmm. Yes. Yep. So, but it's not the way you think it is. um, you can have commerce. Comma is considered a part of an expression. You can have a comma expression instead of a semicolon. So it gets a little bit messy when when it gets to that point. So at this point, it's probably just best to say that an assignment has to be followed by a semicolon in order to make a statement. Yep. All right. So are we all good in terms of the role taking activity? We good? Oh, okay. All right. Okay. As you work on this, I will go ahead and work on another example here. Okay. Okay. All right. So let me switch to Supernote, and this is the code presented to the compiler. And we don't even care about the logic of this code. So why are we assigning a 1 to x, when x is greater than y? I don't care, okay? I'm just, looking at the syntactic perspective and try to figure out what the compiler is going to think of this, okay? So that's what we are going to do. So are we ready to move on to this, or you guys are still doing the role taking activity? We good? All right, okay. So from the compiler's perspective, it will first see the word if, okay, and it will go like, oh, okay, I know only one kind of statement that starts with the terminal if. Okay, so I'm expecting the rest of this to be parts of a conditional statement. Okay, open paren is great. Okay, that's exactly what I'm expecting. An expression, I mean, a condition is also exactly what I'm expecting. Great. A closed paren is also what I'm expecting. Great. So now by the time I get to X, I go like, okay, I know I'm expecting a statement at this point. Um, X does not start a conditional statement. So the only other statement I know at this point is an assignment statement. So now we go like, okay, this has to be the left-hand side of an assignment statement. We see a single equal symbol. Great. We see another expression here. Okay, great. That those are all components of an assignment. So these three combined is going to become an assignment. And then the assignment followed by a single semicolon will become an assignment statement. This part is identical to what we had before. Okay, so the assignment statement, and then the compiler goes like, okay, I see that an assignment statement is really just a statement, which is what I'm expecting as the then statement. So the then statement is a component of the conditional statement. So the compiler is quite happy at this point, saying that, okay, I figure out the then statement of the conditional statement. So now what follows this is an optional else statement, right? The else part has to start with the word else. But we are not seeing else here, we're seeing y, okay? The compiler then comes to the conclusion of, okay, there are no else part to this statement. Then you guys go like, but what about this else here? The compiler cannot see it yet. So now the compiler goes like, okay, I got my then statement, I got the close paren, I got my condition, I got my open paren, I got the terminal if, I'm good. The conditional statement is now completely parsed, which becomes a particular statement. So it's just the same, a statement, okay? So the compiler then moves on to the next statement, which starts with y. So I'm just going to shortcut this whole thing. You look at this whole thing and go like, oh, okay, this is just another statement. Cool. Then it sees the terminal if. You cannot have a variable named else in C++. So all the terminals that we use as a part of a statement cannot be used as a variable name. So at this point, the compiler goes like, hey, what is else doing here? We are not right after the then statement of a conditional statement. So at this point, the compiler is going to go like, nope, this does not work. Your program is not compiling. The compiler says, I don't know what you're trying to say here. Is that okay? But to a person, it might still make sense, okay? Especially if you use indentation for both of these statements, and then you use and then you drop one level of indentation for the else. So for Python programmers, they go like, I don't see why this is a problem, but in C++, it is a problem. This is another reason why I do not use Python to teach this class. Because if I did use Python to teach this class, you guys would actually have to undo what you learned about Python to make your code work properly in C++. So if you guys want to do some extra work for no particular reason, hey, who am I to say no, right? But I don't want you guys to kind of waste the time to learn something that is not going to help you in CISP 360. This is by no means me saying Python is useless. It's just that learning Python to learn C++ is not the most effective way to do it. Am I good so far? All right. All right. So now we're going to go back to what you mentioned earlier. What if I got multiple things to do in the then branch or else branch of a conditional statement? So in order to address that, we have to go to block statements. So we just have to look for block statement. There we go. So now we are on block statement. So this time we're going to go straight to the syntax, in terms of the BNF. So the BNF says a statement can expand to a block statement, which is still a token. A block statement expands to open brace, a terminal. Okay, so you have to type open brace exactly the way it is. And it has statements as optional. In other words, you can close the open brace right away with a close brace. That is still considered a block statement. It's just that it is empty. Okay. Well, if you think about a block statement like a typical folder in a file system, can you have an empty folder? A folder that has nothing in it? Yes, you can. So it's the same idea. Okay, it means the content of the folder is kind of optional. You can make an empty folder if you want to. So statements is using the kind of recursive definition. So statements as a token can expand to a single statement, but it can also expand to statements, which is itself recursively, and followed by a single statement. So this is how we can specify you can have as many statements as you want inside the braces. Are we doing okay so far with this notation? Yes? No? Kinda? Okay. Yes. Okay. So now we can now say this is so if we want line 2 and 3 to be both a part of um, the then branch of the conditional statement, then this is not going to work because we just talked about this, right? Because line 3 is really not a part of the conditional statement. Line 3 is a statement following the conditional statement. The only then branch of the conditional statement is just line 2. So we talked about that earlier. So if I were to use the correct indentation, I do apologize, the slash is actually off here. It would be the same thing as this. But to address what you said earlier, what if we want both x gets x times 2 and y gets y minus 1 to be both in the conditional, in the then branch of the conditional statement? Then we introduce the braces. So this is how we can say, oh, by the way, let's group these two statements into one single block statement. So that means the then statement of this conditional statement is this entire block, because everything from the open brace to the end brace is considered one single block statement. Now, what can you have inside the block statement? Whatever statement you want. It can be assignment statements like what we have here. It can be conditional statements. It can also be any statement type that we will be talking about. There's no restriction. A statement is just a statement. Are we doing okay so far with the block statement concept? Okay. Yep. Not bracket, braces. Yep. Because I want to correlate the line number to whatever I had before. because I want to kind of go like, okay, the original line two is still the line two here. The original line three is still the line three over here. So that's why I use line 1.5 and line 3.5. They're just comments. I mean, the line number doesn't really, it's just to convey which line I'm referring to. So think of the line number as just an ID. That's all they are. Yep. They're not really conveying exactly where the line is. They're just saying, oh, okay, I refer to line 1.5 to refer to where the open brace is. That's basically what the line number, quote unquote, is for. Mhm. All right. So do we have any questions about block statements? Because that's pretty much all I have to say about block statements. It's really just a way to package multiple statements into a single statement to be treated as a single statement. Now, there's also a little best practice part, which is basically saying anytime you have a conditional statement, use braces. Even if there's only one single thing to do, even if there's only one single statement at the time that you write it, use a block statement anyway. Because if you always use block statement, always use the open brace and the close brace, then anytime you want to add any additional statements into that block, you don't have to worry about, oh, wait, I need to turn this into a block statement now, because you start with a block statement to begin with. Okay. The extra punctuation mark of open brace and end brace, they do not introduce inefficiency when the program is running. So that means using braces or using the concept of a block statement when it is not really needed costs you nothing other than two more characters in your code. But it does help you organize the code later on because if you decide, oh, I got some more stuff to do in the then branch or the else branch, then you don't have to worry about, oh, now I have to think about, putting an open brace and an end brace, and where do I put the open and the close brace? You got it done already. Okay. So that means the way I write this code, okay, let me give you an idea of what I mean by best practice. So let me get rid of this stuff. It's not really needed anymore. Okay. So the way I write this code on this side, I typically do it like this. In other words, I introduce all the containers first. Then I backfill what should be going into the containers. Oops. And there we go. And also, what is supposed to go in here. So this is the order of how I write my code because I then never really have to worry about matching braces with the opening. Okay, because if I have block, inside block, inside block, inside block, and I don't do it this way, then when I have to close the braces, I have to go back to match the open braces. If I do it this way, they're automatically matched already because I always open and then close right away and then backfill whatever is supposed to be between the braces. So, but that's just my personal style of writing. After years and years, I found that this is the best way for myself so that I don't have to worry about unclosed blocks or having too many closed braces and so on and so forth. This way they're always matched to begin with. But that's a personal style of coding. You can take it with a grain of salt. Okay, if you say I can do it in a different way and it's better, cool, not a problem. All right, so I think we are about out of time today. So just a reminder, next Monday, we will also meet in this classroom for the optional lecture. If you cannot make it here, that's okay, but make sure you watch the video before Wednesday. Preferably, sometime on Monday. As soon as possible is usually better, but if you don't have time on Monday, do it sometime on Tuesday. Really do it before this class on Wednesday. Usually it is right after, but I have another class right after this class, so I don't have time to post it. So if anything, it's going to be at about noontime because that's the end of the lecture of the class following this one. But sometimes I don't remember. So if I don't remember and you don't see anything by noontime or 1 o'clock, just nudge me, send me a ping, using email and go like, okay, can you kindly upload the video, please? And I would just go like, oh, darn it, forgot. Yep. Okay, wait, wait, wait. Let me turn off the recorder first, unless you want to be recorded.